Hello everyone. Now in this video we will talk about torsion. So torsion is shown here by this hand signal that is rotating basically the shaft either clockwise or counterclockwise. So it's either one, this figure is shown, it's twisting it in that direction as I show here. Now the equations that we do need for here. First actually let's say we have the shaft. The radius is C, and at any point let's call the radius rho. So for a shaft like this, the maximum shear is going to be at the very edge, so at radius C, and at any point we have actually shear tau. Now tau is simply rho over C tau max. Tau max is the torsion times the radius over the polar moment of inertia J, and tau is the torsion times rho, which is at whatever radius we want tau, so here we took rho, over the polar moment of inertia J. So you see how we relate those two to get this. Now moving on, one thing I want to discuss quickly is power transmission. Let's say we have a motor shaft that's rotating the shaft, so the power is simply the torsion times the angular velocity, and this is also can be written in another form, which is 2 pi f g. Now f is the frequency, and this will be in hertz. Now the last thing I want to talk about for torsion is the angle of twist. Now notice the difference from here to axial load. We don't have elongation here, we have an angular twist. Now the general equation is the integral from 0 to L dx dx over jx g. Now notice this is very similar to the axial load equation, except instead of force we have torsion, and instead of I we have J. So integrating this from 0 to L we get dl over jg, and let's say we have a shaft with multiple cross-sectional areas, or we have more than one torsion on the shaft. To get the final twist we just sum the angle twists.